as a mechanical designer of space products. I'm also working part-time with a small startup in the US called LifeShip Inc. I work as a missions manager, community experience builder, and capsule designer for sending DNA to space. That's been really, really cool. My background is in aerospace engineering. I enjoy doing outreach and rock climbing. So that's me in a nutshell, but this panel is about climate change and climate change from space. So I'd like to introduce you all to Eric Choi, who we have sitting here next to me. So to let you know all about Eric, Eric is a director of business development at GHGSat. Over the course of his career, he has held positions of increasing technical and managerial responsibility in both the aviation and space sectors. The latter included work on KeySat, the quantum encryption and science satellite, the metrology MET payload on the NASA Phoenix Mars lander, the Canadarm2 on the International Space Station, shout out to Canada, and the RadarSat-1 Earth observation satellite, and the MOPIT measurements of pollution on the Troposphere instrument on the Terra satellite. He was a participant at SSP 1999 in Thailand, a teaching associate at SSP 2003 in Strasbourg, a visiting lecturer at a number of subsequent SSPs, and a team project chair at SSP 2014 in Montreal. From 2011 to 2013, he was the alumni representative on the ISU Board of Trustees, and he has served on the past executives of the Canadian and US Alumni Associations. He's an engineer by training and holds a bachelor's in engineering science and a master's in aerospace engineering, both from the University of Toronto, and also an MBA from the Schulich School of Business at York University. So welcome, Eric. You have a super cool background of things going from engineering to business and everything in between. So yeah, maybe you can get started on telling us a little bit more about GHGSat, what's going on there, and the involvements with climate change.
Well, Shaziana, thank you so much for this opportunity to speak today. Maybe as a bit of a caveat, when you say that we're next to each other, that's really just in a metaphorical sense, because I'm actually in Toronto, which is sort of in the middle of Canada. And I believe there's quite a few kilometers, at least physically, between the two of us. And of course, all tied together virtually, some of that distance disappears. Maybe just a bit of a shout out as well to the great crew of SSP 2014 in Montreal. So I'm wearing this shirt in your honor there, all of us who had that great summer at ETS and HEC in Montreal. So the topic of space and climate change, I think, ties into the wider perspectives that the height and the breadth of space gives in tackling these environmental issues. And they're really intertwined, I think, between exploration and introspection, looking outwards from the Earth and looking down at the Earth. So just in this month, in July, of course, was 52 years ago that in 1969, human beings first set a foot upon the moon on the Apollo 11 mission. And when the astronauts, when Neil Armstrong and Buzz Aldrin were bouncing around there on the lunar surface, those were striking historical images. But I would argue that even more powerful images was when they and the other Apollo astronauts looked back at the Earth and saw this really fragile little blue marble sitting there in the darkness of space. And that compelled this remarkable overview effect of the fragility of our planet, which I think endures to this day. And I don't think that it was an accident that the first Earth Day was celebrated, took place less than a year after Apollo 11 in April of 1970. So space has always, I think, since the dawn of the space age, provided us with this compelling perspective of the Earth. And it's more than inspirational. It's very practical. For example, according to the World Meteorological Organization, of the 50 essential climate variables that the WMO has identified, 26 of those, more than half of those, can in fact only be effectively monitored from space. So I think this is something that speaks very strongly to the importance of space and space flight in helping us monitor our environment and ultimately mitigating the challenges of climate change.
Yeah, it makes sense. I'm really glad that you talked about Earth as a blue marble and perspective from the moon, and even just that vantage point, kind of heading towards like the overview perspective and overview effect. I think that needs to be talked about more and somehow relayed to the public outside of space. So that's really cool. So thanks for including that as well. And I agree, there's a lot of introspection and connection that has to happen here. I'm curious, since we're both in Canada and GHGSat is a Canadian company, how are things looking in Canada, and what have the involvements been? How are we looking on an international scale?
Well, Canada certainly plays its role both in Earth observation and in contributions to climate change. And it's important to emphasize that as these are global issues and global challenges, it calls for a global effort. So these are missions and satellites that NASA has done through the Landsat program for so many decades, or the European Space Agency through the ERS, and now the Sentinel series and the Copernicus program. And relative to ourselves as Canadians and the size of the Canadian space effort, we're not the size of NASA and we're not the size of the European Space Agency, but we do our share. So as some examples, you mentioned this instrument called MOPIT, measurements of pollution in the troposphere. So this is an instrument on the Terra EOS AM1 satellite, which is a NASA spacecraft. And this instrument looks at carbon monoxide concentrations in the troposphere, so in the lower atmosphere where we are. And carbon monoxide is of course a product of incomplete combustion and has significant effects in terms of both human health and environmental and climatic effects. There's another Canadian instrument called OSIRIS that is, again, speaking to international collaboration. This is on a Swedish satellite, Odin, which has been taking profiles of stratospheric ozone for a number of years. There's a Canadian small satellite called SciSat, which has also been operating for a number of years, looking at different chemical species, including ozone, the vertical distributions through different layers of the atmosphere. And, your company, Shaziana, MDA, has led for decades a series of RadarSat satellites that has been monitoring the surface of the Earth since 1995. What has been really exciting, I think, in Canada and in other places around the world is what we're seeing is that these government efforts, these government flagship missions, are being complemented by other efforts in the commercial sector, in the private sector, in some cases in the philanthropic sector, doing space projects to bring complementary and augmenting data sets to these government missions. And I think that's tremendously exciting.
That does sound really exciting. So from involving these other types of sectors, the commercial, philanthropic, how have those been assisting and evolving the situation, or not assisting if they aren't?
Right. So as I said, these are very complementary efforts, and maybe as a bit of an example, I can talk about what we at GHGSat do. So we at GHGSat, we have a fleet currently consisting of 3 satellites. Our first satellite was a technology demonstration that was launched in 2016 called Claire. And our first 2 operational satellites were launched a little more recently. So our first operational commercial satellite called IRIS was launched last September. And our most recent satellite, Hugo, was launched on the SpaceX Transporter-1 mission back in January of this year. And in case you're wondering where these names come from, we actually name our satellites for the children of employees. It's just a nice way to remind ourselves of the mission that we're involved in and the importance of what we're doing for future generations. So our satellites are of the nanosatellite class. So if you, this isn't something like an NVSat or something that's like the size of a lorry or something like that. These are much smaller. Our satellites are in the 15 kilogram class, and if you can think of the dimensions, it's about the size of a microwave oven, basically. And yet, for this small size, we're able to do what we think are pretty interesting things, and things that fill a niche that other satellites currently are doing right now. So our speciality is our ability to look at greenhouse gas emissions, specifically methane, at a very high spatial resolution. So under 30 meters. And what this means is that we can attribute a methane emission right down to an individual point source or an individual facility, be it a gas flaring stack or an oil well or an individual landfill or a vent from a coal mine. Again, this is something that currently nobody else in the world is doing right now. And to get to the point about complementarity, there are many other government satellites that are up there currently. Most notably, one of the notable ones is the Sentinel-5P, which is carrying the Troposphere instrument, and we work very closely with that. It all speaks to complementarity. So what Troposphere does is that they're able to look for methane hotspots on a very wide swath, basically at a regional scale, but at coarser resolution, something on the order of 5 to 7 kilometers. And when they are able to detect, hey, there's a region in this cell of several kilometers of an elevated methane concentration, that's when we can zoom in with something like a GHG sat, bit of looking at it like a microscope, saying, okay, so here's the elevated area, and we can identify that the sources of this emission is from X, Y, and Z facility or plant in this area. And this is a scientific collaboration that we've had with ESRON in the Netherlands very successfully since 2019.
That's incredible that we're able to actually pinpoint specific locations where something is. I'm curious, has anything that has evolved and improved due to these technology developments impacted either policy regulations or something in that spectrum?
Well, that's a very interesting question. I think it touches on a number of things. In terms of influence, what has enabled us to do what we do, and what other people are doing. Planet is another amazing example. Is this whole new space and small sat revolution that has enabled us to develop, build, and launch satellites and instruments at orders of magnitude, a fraction of the cost of what it would have been in the past. To the point where private organizations like ourselves and even now philanthropic organizations looking into potentially satellite missions. So there's a capability there. And you talked about policy, and that's very interesting as well, because in some cases, I would argue the policy needs to catch up with what the technology has and the economics of new space has enabled us to do. So at GHGSat, to use an example, is we've had tremendous success on the commercial side. We have a lot of clients and customers in the energy sector, in the resource extraction sector, in the waste management sector, who want to need to quantify their emissions, both from the standpoint of their environmental obligations as well as their business needs. Because if you're leaking methane, that's actually dollars and euros going out into the air that you can actually recapture and sell as a product. So that uptake has been tremendous, and I think the next interesting step is how do we make the appropriate regulators aware of these capabilities, so and that these technologies are equivalent and provide complementary, in some cases perhaps even superior capabilities to, say, a person driving in a truck with a handheld optical gas imager trying to look at leaks at every single well at in the Permian Basin of Texas, and there's like thousands of these things. It's not necessarily practical or affordable to do that, but this is something that would be very readily done with a satellite. And so I think what will be interesting in the coming months and years is how environmental regulation will be more and more supported by satellite capabilities.
Yeah, very much so. You definitely touched on the next question I was actually going to ask you about is how do we involve decision makers and policymakers into these conversations and into having this knowledge that is coming out of all of these satellites that are observing the Earth and talking about climate change. Can you speak more towards that?
I think there is increasing awareness and appreciation in the policy side and, in the political side as well, recognizing what space technology and satellites can do to help monitor and ultimately mitigate climate change. And I can give an example of that is the United Nations Environment Program is spearheading a new project called the IMEO, which stands for the International Methane Emissions Observatory. And the specific purpose of the IMEO is to help track progress in terms of national contributions and national greenhouse gas inventories towards holding us to that 1.5 degree mean global temperature rise over the coming decades, and to be able to have that objective and timely data to inform diplomatic action when such things are needed. And I mention this is because in the IMEO and in the UNEP, they have specifically called out the importance of satellites, that this is something that we're not going to be able to do unless we have that perspective that is provided by space.
Yeah, absolutely. Definitely need that outer perspective, the bird's eye view, but ultimate bird's eye view in order to get that type of information. Seeing about commercialization a little bit and impacts of different sectors, do we know how much space contributes to the climate change crisis?
Well, that's an excellent question. And I think that's something that has been very legitimately raised a little more recently. And it's interesting to me because for the many decades of the space age since Sputnik in 1957, we've not, for example, had enough launches or had enough. Well, I mean, obviously there were always concerns that are legitimate concerns, but the volume of launches and the quantity of hardware that we're putting into space right now in low Earth orbit, in certain, like sun synchronous orbit, for example, is tremendous. And suddenly that this is something that we do need to think about. So I don't have specific numbers sort of off the top of my head right now. I wouldn't want to misquote anything, but I will say that ourselves at GHGSat and our peers and other organizations, this is something we consider. And in fact, in our cases, for our launches, we retained an independent environmental consultancy to actually do that carbon auditing of the emissions that would be attributed to us out of a launch. So, for example, the SpaceX Transporter-1 launch that put up Hugo back in January. I forget how many satellites that put up. It was quite a few, but basically the carbon attribution, down to our satellite, compared to the carbon reductions and mitigations that would be put into effect over the 5-year course or the nominal 5-year life of our satellite. It's many orders of magnitude more than the carbon emission out of the launch itself. I can give you an example. For example, since the launch of Hugo, since January of this year, we've made over 1,400 measurements of methane, which is equivalent to the carbon equivalent to about 50 million cars being operated for a year. So as always, it's there's a trade-off, and we have to do a proper accounting, carbon accounting of everything we do. But I think the numbers are very much in favor and very compelling that on balance, space is good for the climate.
Right. Yeah. For sure. Again, going back to getting that vantage point and being able to actually make those changes and figure out what changes we need, that makes sense. That
I wanted to. Am I audible?
Yes, please. Sure.
I had one a specific query. Can geo orbit, Clark orbit, we have today direct to home services, on the telecommunication side. Can we think? I have seen in some space conferences some papers related to using geo orbit for energy supply. You see, if you can have some sort of a source of energy from the geo orbit, which can make a well of a difference with regard to the energy crisis. You see, we have so many sources of fossil fuels being used. Even if all the cities were to go for electric and solar, yet the existing power generation plants, they are the real problems with regard to the carbon emission. Can this geo-orbit be a source of providing just 3 satellites there up, can negotiate the whole globe? And I have seen some papers in the conferences, but is anybody doing something serious on these lines?
Yeah, I think geostationary orbit can play an important role in, as you said, in mitigating, in helping to address climate change, both from a monitoring standpoint and, as you correctly say, as a potential source of clean energy. So the notion of solar power satellites in geostationary orbit has been studied and looked at for years. This goes back to people like Professor Paul Glaser in the 1970s. And I think what is exciting is that a lot of both the technological impediments in terms of the power beaming technologies, the power conversion technologies are starting to be solved. Dr. Paul Jaffe at the Naval Research Lab in the U.S. has done a number of experiments in rectifier technology, having good power conversion from the cells to the microwaves and down to the planet. And then, as I said earlier, we're at this very interesting place right now where suddenly launch costs, which has always been a big problem in closing that business case for space solar power, suddenly the numbers really look like they could be starting to work. So that's the clean power generation side. And then on the environmental monitoring side, yes, absolutely. Most of our operational weather satellites for meteorology, of course, and geo. And I'll actually mention as well, in terms of climate change and methane, there is a project on at NASA with Lockheed Martin called GeoCarb, which is an instrument that will look at methane emissions at a hemispheric level, both as a hosted payload on a commercial geostationary communications satellite. So short answer to that is absolutely yes. Geo is a valuable orbit for climate change.
Thank you very much. That's very enriching. You said in 70s the effort started. Any specific work going on now?
I'm not very familiar with this field. I'd have to consult Dr. Google myself as to what's. I know that Dr. Paul Jaffe at the Naval Research Lab has been in terms of the power conversions and rectenna technology. Some of these have been tested recently on the X-37 mission. Yeah, I'm afraid I can't speak knowledgeably about
it's okay.
recent developments.
Okay, thanks.
Thank you.
Cool.
Thank you very much.
Thanks for that. And yeah, now thinking of orbital regens and such, you mentioned about debris in LEO orbit, and I'm glad that you did as well. For my master's, it was very relevant and something I had to talk about quite often. It was very, very relatable to, you know, Earth climate change and sustainability, to space sustainability. What developments do you think still need to happen? We've talked a little bit about progress, being able to have these images and imagery and observations, but what developments, either technologically or otherwise, do you think need to happen to help?
Did you want to talk specifically about the orbital debris problem, or is it sort of climate change as a whole?
If you'd like to talk a little bit about both, that would be great. If you have one preference over one or the other, that's also fine.
Well, it's, you know, I really don't have a lot of expertise in debris mitigation per se. You know, I would encourage people who do have an interest in that to, you know, talk to some of the ISU alums who work at places, you know, cool places like Astroscale that are doing tremendous work in removing orbital debris. I can provide assurance that all of GHGSat satellites comply to the IEDC 25-year deorbit requirements. We don't have propulsion on our satellites, but they're in a low enough orbit, and, you know, the ballistic coefficient is such that we will come down in 25 years. And this is an important consideration because, you know, I don't think anybody wants to get into that ironic place where an environmental satellite becomes a bit of an environmental issue. And unfortunately, I have to say, you know, something like EnviSat, for example, which is a huge spacecraft that you know, did tremendous work for Earth observation for 10 years, and then unfortunately, at the end of mission, it's still up there. And you know, reading some of these debris mitigation papers, you know, a number of them use EnviSat as an example of a large object that could be a good candidate to be deorbited by one of these new technologies. So you know, we're always walking a fine line that it's, you know, it's environmental. We want to be the solution and not you know, unintentionally become part of the problem. In terms of challenges as it pertains to climate change and environment and Earth observation, is there is, you know, lots and lots of data. You know, so we've got our data, and then, you know, all these, you know, government missions, you know, the Sentinels and VEERS and so forth, generating, you know, literally terabytes of data. And I think the next challenge is, you know, how do we apply analytics and big data techniques and artificial intelligence to turn that raw data into things that are actionable and can be prioritized people, so that they actually go out there and they shut down that leaking well, or they redesign a facility in a different way to mitigate its effects. You know, that's I think what's coming up. And, you know, I would argue that in many ways that is as exciting. You know, what comes out of AI and what comes out of big data is going to be as exciting as, you know, the sort of fiery rocket launch of putting the hardware and getting the data down in the first place.
For sure. Would you have any proposals on, like, how we can make that data actionable and how we get those to the sources that need it?
Yeah, you know, just as an example of something that you know, GHGSat does, is we offer for free a global methane concentration map called Pulse. So if you go to pulse.ghgsat.com, you can bring this up, and it's kind of neat. It's an interactive map, and you can zoom in and out of different regions of the world, and you can play with the slider and see how things evolve over time. So this is something that we put together as an aggregate of data, both from public sources like Sentinel-5P, Tropomi, augmented with our data, and sort of resampled and interpolated down to about a 2x2 kilometer resolution. And we understand that a number of public authorities and scientists, there we are. That's what. So we can zoom in on Newfoundland and see how we're doing here. It's mostly, it seems to be mostly good in Canada right now, which is fantastic. So this is something that we offer, and then ultimately, I think what's most exciting is when you make the data and the capabilities available to researchers and to scientists and to innovators around the world. There is absolutely no telling what these smart people are going to be able to come up with. Things that I would not be smart enough to even imagine. So as an example, at GHGSat, we're very pleased that recently we were selected to be what's called a third-party mission under assessment under the ESA EarthNet program. So this is something that will make available to scientists our data, and sort of in parallel to that, we have an announcement of opportunity through the European Space Agency and through the Canadian Space Agency, where 5% of the data from our second satellite, IRIS, is made available for free to the scientific community. So let's see what's out there. Let's see what's smart people come up with this data. And as I said before, what these people come up with is going to be as exciting and perhaps even more exciting than. And I'm an engineer. I'm a hardware guy, so I like rockets and satellites and stuff. But you know what? These data products that people are going to come up with are going to be just as fantastic, just as cool, and just as important.
That's super cool. I didn't know.
I would like to know one more thing. We are nearly 3 to 4 decades, you see, globally to look at the climate change. And now it's becoming more and more stronger that we need to have the intergovernmental efforts. Having attended in the past 1 year so many climate related conferences, I find one gap, and ISU and other stakeholders can do a big difference. That is to link the academic institutions, you see, and the research institutes all over the world, and with an element of civic concern also. So that involves a lot of propaganda and communications from it could be UNOSA or ISU to bridge people, especially in the academic institutions, so that there is an element of pressure building activity which looks at the geo orbit and other orbits. For example, I can remember at ISU a project Shine. It was done in 2011. Which used the best of satellites for monitoring the health, in African continent. Now, for so many decades, the intergovernmental concern and the targets are becoming more and more precise, and people are coming with that agenda and targets. I think space community has to bring in different stakeholders so that there is something like a vision, an agenda, and an action plan. If you want to bring down even a micro level energy reduction by the space technology. Actually, now we are, my impression is we are using space technology for telecommunication and also for geospatial data. And now slowly the synthetic aperture radar has started giving us some sort of a quantification of the climate changes. But what is missing is an integration of community-based and nature-based solutions for climate change. They are becoming very strong, very, very strong. And the documentation, I can quote you here, the International Institute for Environment and Development, UK, it's at London. they do a good number of webinars exclusively on community-based and nature-based solutions for climate change. So climate action is already on the ground, but from the space to have some sort of a technological handholding why not this way? Why not see only the research institutes and academic endeavors can look at these issues. So I think it's time that ISU creates some sort of a space to look at these issues. If climate change is certain, climate action can also be certain from the space segment.
Exactly. You definitely touched on something I was just thinking about as well, of that there is that gap between stakeholders and the data and stakeholders and the action. So that's a very good point for sure. So thanks for bringing that up. Yeah, to move forward from there, that was a good point about that gap that needs to be filled, and maybe different sectors or ISU or SGAC or universities or something can somehow fill that in. Do you have more thoughts to share on that, Eric?
Well, I just agree with everything that has been said. And, with ISU and the three I's, the interdisciplinary, international, and cultural, of course, we have been the pioneers of that. And it is really a recognition of the reality that environment and climate change being a global issue that doesn't recognize artificial borders that we just happen to draw on a map, that it demands a global and international solution. And fortunately, these things are happening. So there's, the World Meteorological Organization, COS, the Committee for Earth Observation, GEO, the Group for Earth Observation. And, now we have, formal MOUs in place between ESA and NASA, for example, to, collaborate on climate change and, in terms of coordinating, the Copernicus program with, NASA's Earth Science program. So, international is key, and, ISU and SGAC were always right there at the forefront. I'd like to touch on actually one more very interesting point that was brought up there. We talked about governments in the private sector and academia institutions, and the one thing that was brought up here is the local communities. In many cases, these would be, disadvantaged peoples that unfortunately are going to bear the brunt of the consequences of climate change. And how do we bring them to the fore and have their voices heard as well? In terms of solutions, and I'm actually going to give a bit of a non-climate change example of a book that I just read. So the book is called "In the Hot Zone" by Richard Preston, and it's actually about the Ebola outbreak that took place in Western Africa in 2014. You might think this is kind of an odd book for somebody like me to read in the middle of a pandemic, but I just got to be interested in the topic. And what was instrumental in stopping Ebola in West Africa was that there was a recognition and a leveraging of local indigenous knowledge and wisdom. So there was something, so apparently, and I didn't know this, in these parts of Liberia and Sierra Leone, basically generations ago, smallpox had swept through these areas. And so the local people initiated what they called the ancient rule, which was, if you see somebody with X, Y, and Z characteristics or symptoms, you put them in a hut outside of the village and you leave them there until they get better, or unfortunately, if they pass away, then you burn the hut. And this was a piece of local knowledge that endured for generations. So when Ebola struck, they were able to leverage that knowledge and say, remember the ancient rule. This is something we need to do, and those practices turned out to be pivotal to stopping the Ebola outbreak in 2014. So looking at the bigger picture now in terms of environment and climate change, I would argue that similar initiatives have to be made to reaching out and engaging local communities and local and indigenous knowledge, that ultimately we're all in this one planet together to solve the climate change crisis.
Absolutely, and you're totally right there. I definitely need to think about that.
This should be able to. It should be able to.
And also the fact that indigenous communities often already have this knowledge that we need. The crisis becomes this big, entangled, integrated situation where it's climate and policies and money and everything, and we just don't have the systems in place. But when you think back to, just like you said, with indigenous communities and ancient knowledge, it's there. We just need to raise that up. And
I would like to add to both of your observations a very important thing. For example, you see, we had the biological diversity also focused in the UNCED Earth Summit 1992. And we today have, for example, if we take a case study of India, a Biodiversity Act, which makes even the villages, small hamlets, to go for biodiversity documentation. Just imagine for a while the pharmaceutical world, billions of dollars corporate giant for the Medicare, for the healthcare. And we have the traditional indigenous knowledge in the form of medicinal plants, in the form of biodiversity, which can cut down a significant expense on the common man, and so that we switch over to the nature-based solutions for healthcare, rather than this chemotherapy and the chemical-based, the pharmaceutical intervention. So space has got a role to play here. So on the one hand, at the ground level, go to inventarization of the indigenous knowledge and the practices. For example, if a simple medicine can give you a preventive, antidote, then we don't require so much of vaccination. See, vaccination is a very big industry today. We create a pandemic, then go for vaccination. And United Nations Secretary General says there's no vaccination for climate change. I think there is a vaccination for climate change. That is preventive strategy. The ICUs, the steroids, and oxygen, these are all curative approaches. For a while, we should think of a preventive approach, wherein, as you rightly pointed out, for hundreds of years, people are living through the pandemics. People are living through all the sorts of man-made or natural or technological disasters. The human culture is having a heritage.
To bring in those cultures and heritages and everything. So
absolutely, yeah.
Move forward from there and open up the floor to other questions. So if other people would like to maybe use their raise hand symbol instead, and then we can organize those who get to ask questions. We do have one question in our poll up, so I'm going to head over to there as people maybe start thinking of questions, and otherwise I definitely have far more that I could ask as well, so no worries there. But yeah, if anyone would like to chat, then to raise your hand would be great. So first question that we have here is talking about Clark. Can space at Geo-Clark orbit provide energy needs on Earth? I believe we kind of talked about this a little bit. Hey.
We did, and the answer is yes.
Good, short and sweet. That's really awesome. So that is the one question we had in there. So thanks for that question. I will move us back into the room here. And so again, if anybody has any further questions that they would themselves would like to ask, please do just raise your hand. We did touch on pandemic a little bit, and I'm curious, how has things changed over the pandemic? In some ways, I know I've heard things got better at the beginning of the pandemic, but then also I'm always thinking about how in the medical field, you can't really reuse stuff. You can't really reuse things that can harm you. So how have things really changed over the course of the pandemic?
I think the pandemic has impacted different sectors and obviously different people very differently. Obviously, for the most part, it's been horrible. From the standpoint of space, it's been interesting, I think, that for the most part, many space companies have continued to do well through the pandemic. I mean, just as an example, Shaziana, your company MDA has continued to hire and to expand and to pursue a whole bunch of exciting new projects, including another follow-on to RadarSat. And for us at GHGSat, we've basically doubled the number of employees over the course of the pandemic. And you probably may have seen our press release recently that we closed our series, our second tranche of Series V financing, which is very exciting, and that's going to pave the way to a lot of exciting things, including completing our constellation. I think the reason for that is that obviously the pandemic and saving lives and mitigating the pandemic is the highest priority. But throughout all that, other priorities have not gone away. So climate change is still something that we need to solve. If we look at other space startups, I talked about Astroscale earlier. The pandemic has not made the issue of orbital debris mitigation go away. And as we, as a civilization, as a world, slowly come out of this pandemic, as they say, to try to build back better and maybe to have a little bit of a better world than before the pandemic, we're going to really have to double down and address these other pressing human needs beyond the pandemic, and space plays a huge role in that.
Absolutely, yeah. I think the goal is definitely to build a better future, make those solutions to our mistakes, kind of thing, and yeah, make that future better for who's to come. Looking forward to the future, how do you think, or do you think that these technological advances and processes can assist in the future of interplanetary advancements for humanity?
Interplanetary advances. Wow.
To say inhabit Mars.
I think yeah. Well, I think it really goes hand in hand. That if as we in the space geek community probably hear this a lot, that why are we doing all this stuff in space? Why are we exploring space or going to other planets when there are so many problems on Earth? And I know I'm probably speaking to mostly like-minded people. I think that we recognize that space is not an activity that is isolated in and of itself, that it opens new horizons, both technologically, scientifically, but as I opened my talk with the Apollo overview example, both inspirationally and spiritually as well, that ultimately drive us towards solutions to our home planet that otherwise we may not have even seen. So those who know me know that I'm also a huge fan of science fiction as well, particularly Star Trek, and one of the things that always appealed to me about Star Trek, about strange new worlds and boldly going where no human has gone before, still appeals to me. But there was another aspect of Star Trek that appealed to me, was that every time they went back to Earth, the Earth was this like almost utopian garden planet where the air was clean and the sky was blue and people were getting along. And as much as exploring space and building that Star Trek future is, I want to be a part equally, if not greater, to build that utopian world, and then from that blue origin, so to speak, as a launching off point to even greater adventures out in the solar system and ultimately out in the galaxy. So It all comes together. Exploring space and protecting our home planet go hand in hand.
Absolutely. I think that's a very on point and wonderful answer.
Point C.
I'm thinking about, you touched a little bit on arts and talking about Star Trek. What crossovers can we possibly see with climate change into STEAM and arts?
There's a growing field of what's called cli-fi, which is basically climate fiction, of people, using science fiction and using the genre in the way that it's always been used, as not so much as predictive, but illustrative of, well, this is something that could happen if we keep doing things this way, or this happens. But things could get worse, but things could also get better if we do things this way. And the climate fiction, what's interesting to me, at least the stuff that I've read, is generally optimistic in the latter, that trying to illustrate, if we do these things, we can actually better ourselves and save our civilization on this planet. And I think that, to me, is most appealing about science fiction or speculative fiction as opposed to other genres, because it's not just about who we are right now or the way the world is right now, but what it could or can or should be if we make the effort and try to better ourselves as a civilization. And as we come out of pandemic, I think that message is more important than ever.
Absolutely. I agree with you on that. We definitely need to be doing better and come out of the pandemic with a better mindset, for sure, of this global collection and connection, and needing to be introspective and making that happen. For the last few moments, I do want to ask you about, again, looking forward to the future. I guess you kind of did already answer this, though, is what are your hopes and dreams for the future when it comes to dealing with climate change?
I think just a world where we have global transparency in greenhouse gas emissions. As they say, we can't control and we can't fix what we can't measure. So I look forward to the day that through space and through other means, that we have objective and timely and reliable means to inventory carbon, whenever and wherever we need, towards mitigation goals that will bring us to that Star Trek world that I'm looking forward to.
Yes, that is super, super cool. Yeah, I think we've pretty much exhausted my list here. I don't know if there's any other audience questions. If anyone wants to use the raise hand reaction symbol, and I can include you. Eric, did you have any final thoughts you wanted to share?
I do have a final thing, which is I'm going to turn the tables on you, Shaziana, and actually ask you, as the moderator, what are your hopes for the future and what you'd like to see?
I really liked your answer. I think that was something I've been trying to be able to articulate to myself a lot in the past is, yeah, I want to see this transparent world where people work together, people know their place, we all have an understanding. And I think this kind of sets into what I see of Indigenous culture in a way. I don't know, I'm not Indigenous, I don't know a whole lot there, but from what I've seen, it's very community-based, very respectful, very understanding of the world around you. And that's something that I'd like to see in the future. And obviously, space geek, I want to travel to space, I want to work and live in space and be an astronaut, but we need that community mindset of the world is one, we all live on spaceship Earth, we need transparency, we need to have an understanding of each other. I think a lot of it comes down to a bit of a complete reform of systems, maybe, thinking a little nihilistically there, maybe. But yeah, I think those are my kind of thoughts towards the future in a little less of a concise nutshell manner. Curiously, I know you are an aerospace writer, going backwards to arts a little bit. do you think you would include, or have you included things about climate change in your writing before?
It's funny. I'm embarrassed to say that I haven't yet directly addressed climate change in any of my stories. For perhaps obvious reasons, a lot of my stories are involved with space, but I do have a new unpublished story that something happens as a result of climate change. But that is, definitely something I'll be looking, more at in the future.
That's really neat.
So as a self plug, if you're interested
Yeah.
in that part of my background, so you can follow me on Twitter at Aerospace Writer. And you can also see my website, which is aerospacewriter.ca. And I'll just type it in the chat, actually. So that's my Twitter handle. And then,
I'm glad you did it.
well, shameless self-plug.
Go for it. No, that's what we're here for.
I hope I spelled that right. It's aerospacewriter.ca. I think I spelled that wrong. Oh, whatever. Yeah, you'll figure it out.
Yeah, that is super cool. And part of the reason I asked too is A, because I knew about it, and B, since I'm just realizing some thoughts here as well. Something I've thought about before is someone had mentioned trying to write a utopian novel once, and some of the ideas that I have is like, can't we just live in this utopia for once? and so I was curious to know what direction your writing might go as well.
Well, we can write about it, but what appeals to me about ISU people like yourselves and the thousands of alums that are out there is we're not just dreamers, we're doers. And collectively, all of us in ISU all around the world, and all these years and generations of classes, we will make that positive difference to heal our own planet and then reach for the stars.
I love that. I like the sound of that. Let's heal our planet and reach for the stars. And on that note, I think that's a great place to end our session. Thank you so much for your conversation today and talking all about climate change, answering all of our questions, and enlightening on the issue.
Well, Shaziana, thank you so much for this opportunity, and thank you to everyone who attended this session. Please be safe and be well, and look after each other and look after the planet.
Absolutely. And same to you. All the best. Thank you so much.
Take care.
You too. Bye all.